Okay, so the titration curve, is an acid. It's a weak acid, so it's going to come up a little bit, and then it's going to buffer. It's going to be a small slope here, and then we're going to hit the neutralization when we have the 40 milliliters sodium hydroxide, and then we're going to go up, and when we get to the top, the sodium hydroxide, not exactly flat, that's too flat, but that's the sodium hydroxide. And this scale over here is the pH. So we could find the pH at the equivalence point, and we could find the half equivalence point pH too, which we'll do. And in terms of the neutralization, anytime you're doing a titration, for the first half of it until you get to this equivalence, when you're adding a strong base, so we're adding the strong base, this is just a stoichiometry question. So we have 40 milliliters, 0.1 molar. So that means that we've added 0.004 moles to get to here. And that means that there must have been 0.004 moles of the HF. And 0.004 moles of the HF divided by the number of liters we had gives us a 0.27 molar of the HF. Now we haven't done any pH calculations. We'll do that next. So the next two questions say, find the pH of the solution at the equivalence and show the half equivalence on the titration curve and explain how to find the pH. Okay, so the first question says, find the pH at the equivalence point, right? So that's here. We want this pH at the equivalence point. Now, what's in the solution here? Well, that's from this stoichiometry. That is, we have water, right? We've put equal amounts of this, equal number of moles, so these are gone, no excess. We have water and NaF, and it's this conjugate base of the weak acid HF, the F minus ion, that's going to cause us to have a pH here that's not 7. All right, so that's the first thing. Now, what is the concentration of that F minus ion when we're at the equivalence? Well, if I use 0.004 moles of NaOH and I use 0.004 moles of HF, that means that I made 0.004 moles of this. So what we have to find out now is how does that 0.004 moles of the F minus ion, how does that cause a pH that's not 7? And you know how to do that, but I'll do it for you in a sec. And then the second part of this question says, find the pH at this half equivalence point. We'll call this B. At the half equivalence point, what's the pH? Well, that's the easy one, because that pH is going to equal the pKa of the weak acid. So that's going to equal the pKa of the HF. And I'll do those and come back.